Hello friends, welcome to Learner's Planet. Friends, this is our second session for algebraic identities. In the previous session we discussed good number of identities. We did some problems based on identities. In this session, I'll be taking more problems based on algebraic identities. But I would suggest you to attend the previous session. If you are not clear about the basic identities, you will face difficulty in this session, right? So do attend the previous session before you come to this session. Now you have your paper and pen with you also, so you just try to solve the problems on your own, then match your answer and solution with mine, right? So gradually you'll be gaining the confidence in algebra and algebraic identities, right? So let's begin today's first problem. Now we have to simplify the this expression and more such expressions. Now before you start multiplying 175 to 175 and the other terms as well, you just observe the pattern like carefully. Here you can observe that it is 175 square, here it is 25 square, and here it is 2 times 175 into 25, right? Now you just try to recall the algebraic identities a plus b whole square. What that is a square plus 2ab plus b square, right? If I put a is 175 and b is 25, what will happen? It's 175 square plus 2 into 175 into 25 plus 25 square, right? And this same thing, isn't it? That means this thing can be written as a plus b whole square. That means 175 plus 25 whole square, right? Now what 175 plus 25? That's 200. Now what's 200 square? That's 40000, right? So if you make this multiplication, it will be really very tedious. It will take your 5 to 10 minutes, right, to make this calculation. And if you can use this identity, it will be very simple for you, right? So in exam, if this sort of question comes, then you have to go for this identity. Getting me? Let's do one more problem. Similarly, we have this. Here you can see this 322 square minus 2 into 322 into 22 plus 22 square, right? So I can write it as a square minus 2 ab plus b square. Now a square minus 2ab plus b square is what? It's a minus b whole square. A is what? 322. B is what? 22. So it's 322 minus 22 whole square, that is 300 square, and that is 90000, right? The problem just can be solved in 2 simple steps. Okay? Similarly, over here it's 0.76 whole square plus 2 into 0.76 into 0.24 plus 0.24 whole square. Let's make a comparison. It is a square plus 2ab plus b square. That is what? A plus b whole square. That means it is 0.76 plus 0.24 whole square. Now 0.76 plus 0.24 will be 1. So it's 1 square, and that's 1, right? The very big calculation, and the answer is very simple. That's just 1, right? So if you can use the algebraic identity, the problem will become very simple, right? Now here it's 7.83 square minus 1.17 square. So that's, and here it is 6.66, right? So that's a square minus b square can be is compared with a square minus b square. Now a square minus b square can be written as a minus b into a plus b, right? So it can be written as 7.83 minus 1.17 and 7.83 plus 1.17 by 6.66. Now 7.83 minus 1.17 will be 6.66 into 7.83 plus 1.17 will be 9 by 6.66. So finally the answer is 9, right? As simple as that. Okay. Now friends, here we have another pattern of questions. So just watch carefully. How do we find the value of this expression when this expression is given, right? Here value of x plus 1 upon x is given and we have to find out the value of x square plus 1 upon x square. So what you do is, just watch carefully. Now just square both the sides. Right? So it will be x plus 1 upon x whole square and that will be 121. Now this is what a plus b whole square. So how that will be opened? That's a square plus 2 this into this. So x into 1 upon x plus b square and that is equal to 121. Now this is what x square plus x and x will be cancelled plus 2 plus 1 upon x square and that is 121, right? Now we want the value of x square plus 1 upon x square. So what that will be? Just shift this 2 to this side. So it will be 121 minus 2. So that's 119, right? So if x plus 1 upon x is given, you can easily calculate the value of x square plus 1 upon x square like this. I hope you are getting me. Now in this case x minus 1 upon x is given. So just follow the same procedure. Square both the sides. So it's x minus 1 upon x whole square is minus 1 square, that's 1. Now expand it. A minus b whole square, so that is a square minus 2a into b plus b square, right? So this and this is cancelled. So x square plus 1 upon x square minus 2 is equal to 1. So x square plus 1 upon x square is equal to 3, right? So when x minus 1 upon x is this, x square plus 1 upon x square will be 3. Easily we can calculate, right? Similarly, here we have to calculate the value of x square plus 1 upon x square and x4 plus 1 upon x4, right? So what we do is this x plus 1 upon, just squaring both the sides first of all. So it's x plus 1 upon x whole square is 5. So it is x square plus 1 upon x square plus 2ab, that is 2, is equal to 5. So x square plus 1 upon x square will be 3, right? Now to get the value of x4 plus 1 upon x4, what you do is you square this expression, right? So this is suppose 1. Now squaring both the sides of this, so I'll be getting, I just write it over here, x square plus 1 upon x square whole square is equal to 9. Okay, now this is what a plus b whole square. Further we can expand it. So it's a square, so x square square plus 2ab, that is x square into 1 upon x square plus b square, that is 1 upon x square whole square, and that's 9. So this is what x4 plus 2 plus 1 upon x4 is 9. That means x4 plus 1 upon x4 is 7, right? So the problem is very simple to do, right? I hope you are getting me. And definitely at least one problem of this pattern will be asked in your exam. So be very, very clear about it. Just practice some sums and you will be able to do them easily. Now friends, we have reverse pattern. earlier we were given this and we were finding out this expression. Now we are given this and we have to find this, right? So what I do is x minus 1 upon x, let's assume it to be a new variable, say p, right? Now x minus 1 upon x is p. So now squaring both the sides, I'll be getting x minus 1 upon x whole square as p square. Now a minus b whole square is square of this minus 2ab, so that's 2 plus square of this. Okay, so x square plus 1 upon x square is equal to p square plus 2. Now x square plus 1 upon x square is what? 66, right? So 66 is equal to p square plus 2. That means p square is equal to 66 minus 2. That means p square is equal to 64. That means p is equal to plus minus 8. Now what p is? It's x minus 1 upon x. So the value of x minus 1 upon x will be either 8 or minus 8, right? So the procedure is very simple once again, right? Let's take one more problem. Here in this case, further I assume x plus 1 upon x as some third variable, maybe p, squaring both the sides, x square plus 1 upon x square plus 2 is equal to p square. So x square plus 1 upon x square is 79. So 79 plus 2 is equal to p square. So p square is equal to 81. That means p is equal to plus minus 9. And what p is? It's x plus 1 upon x. So the value of x plus 1 upon x will be plus or minus 9, right? Now we have this sum. This is given, and we have to find out the value of 3x plus 5y. Now just observe it carefully. Square of 3x is 9x square and square of 5y is 25y square. So that means there is something, some relation between this and this. So we start with 3x plus 5y, right? And I assume this to be, say, p. Now next step, as usual, squaring both the sides. So 3x plus 5y whole square is equal to p square. Now this is what? A plus b whole square. So it will be the square of 3x plus 2ab plus b square, and that's p square. Now this is what? 9x square plus this is 25y square plus this is 5 3s are 15, 2s are 30xy is equal to p square. Now 9x square plus 25y square is what? 181. From this I write 181 over here, plus xy is what? Minus 6. So it is 30 into minus 6 is equal to p square. So it is 181 minus 180, that's p square. 181 minus 180 is 1. So p square is 1, that means p is equal to plus minus 1. Now what p is? P is 3x plus 5y, and the value of 3x plus 5y is p, and that's 1 or minus 1. Okay? I'm sure you are getting me. In this question, we have to find out the value of 4x square plus 9y square. Now just observe. 4x square, that is square of 2x, and 9y square, that is square of 3y. So just take this expression, 2x plus 3y is equal to 8. Now square both the sides. So 2x plus 3y whole square is equal to 8 square, that is 64. Now just open it up. So that's 2x whole square plus 3y whole square plus 2 into 2x into 3y, right, is equal to 64. Now 2x whole square is what? 4x square plus this is 9y square plus this is 3 2s are 6, 2s are 12xy. The value of xy is 2, so I put it 2 over here. 64. So 4x square plus 9y square is 64 minus 24, that's 40, right? So easy to do. Just a minute observation is there and you are there. Okay. Now let's try this problem. Here it is 3x minus 7y and we have to find out 9x square plus 49y square. 3x square will be 9x square and 7y square will be 49y square. That means we can initiate the problem with this expression. 3x minus 7y is equal to 10. As usual, square both the sides. So 3x minus 7y whole square is 100. A minus b whole square. So square of 3x minus 2 times 3x into 7y plus 7y whole square is equal to 100. Now this is 9x square minus 3 2s are 6, 7s are 42, xy, and xy is actually minus 1. So I put minus 1 over here, plus 49y square is 100, right? Now this is 9x square plus 49y square. This is plus 42. So on that side it will be minus 42. So 9x square plus 49y square is, okay? Isn't it very simple? Just a bit practice and you are like very clear about all this sort of problems. Now friends, let's see next pattern of question. Here we have to simplify this product, right? Now further bit observation will be there. See this is what 3b plus half a, and this is half a minus 3b, right? So what you can do is, it's rewrite this expression as half a minus 3b. Now addition is commutative, so what you can do is, this is 3b plus half a, so you can write down as half a plus 3b, right? And remaining is this way only, right? Now this is what a minus b into a plus b format, right? Or we can say x minus y into x plus y format, right? So a minus b into a plus b is what? That's a square minus b square. That means square of the first term minus square of the second term. So the same thing is over here. So square of the first term minus square of the second term, right? Now this is what? Half a whole square, that is 1/4 of a square minus 9b square, and this is 1/4 of a square plus 9b square. Further, this is a minus b and this is a plus b format, right? So further it is a square minus b square. Do not get confused between this a and the formula, right? Both the variables are different, right? So this is what? The minus sign is between there the two terms, and here the plus sign is between there the same two terms, right? So this will be finally resulting in square of the first term minus square of the second term, right? So it's what? 1 upon a 4a square whole square minus 9b square whole square. Just expand it. It's 1 upon 16a4 minus 81b4. As simple as that, right? So a simple identity of a minus b into a plus b is a square minus b square. We are using to simplify this product. Okay, let's take the next one. Now in this question we have to simplify this. Here it is m plus n by 7 raised to 3 minus m minus n by 7. So just see carefully. What I do is, here it is plus and here it is minus between the same two terms, but here it is cube. So what I do is m plus n by 7 whole square I take apart, and this is what? M plus n by 7 into m minus n by 7, right? So this can be rewritten like this. Now this is a plus b into a minus b format, right? So it's a plus b into a minus b will be what? A square minus b square. So it's m square minus n by 7 whole square, that is n square by 49, right? So simply this can be written as like this. Okay. Now let's see this problem. Here it is x by 2 minus 2 by 5, and here it is 2 by 5 minus x by 2. So both of them are same except this expression is negative of this. So what I do is I take negative as common, or I multiply this one of them as by minus sign. So it's minus x by 2 minus 2 by 5, and I just write this as x by 2 minus 2 by 5. This is minus x square plus 2x, right? Now this is a minus b and this is a minus b. So precisely it is a minus b whole square, right? So it's minus x by 2 minus 2 by 5 whole square minus x square plus 2x. Okay. Now what is a minus b whole square? That is a square minus 2ab plus b square, right? So I just open it up with this minus sign. This is x square by 4 square of this minus 2 this into this plus square of this. Just rewrite the steps carefully. Do not forget to put the signs, correct signs over here. Now this is what? Minus x square by 4. I multiply this minus sign with the bracket, with the terms in the bracket. Then this is this 2 and this 2 is cancelled. So this is 2x by 5. And this minus is plus. So it's plus 2x by 5 plus 4 by 25. So precisely it will be minus 4 by 25 minus x square plus 2x. Okay. Now we just have to simplify this. It is minus x square by 4 and it's minus x square. So it's minus 5 by 4 x square, right? It is 2x plus 5 and it is 2x. So it is 12x by 5 minus 4 by 25. Right? I'm sure you are clear now. Now we have an interesting sum with us. We have to simplify this. Now just observe it carefully. It's x square plus x minus 2 and x square minus x plus 2. So I just rewrite this expression. Right? So this is minus x plus 2. Okay. Now this is, and this is, now this is a plus b and this is a minus b, right? So a plus b into a minus b will be what? A square minus b square, right? So a square is what? X square whole square minus b square is what? X minus 2 whole square, right? Now open it. It's x4 minus this is x square. Now you can open it by as a minus b whole square. That's a square minus 2ab. So that is 2 into 2x. That's 4x plus b square, right? So it is x4 minus x square plus 4x plus 4. I'm sorry, minus 4, right? So the solution of this expression is this, right? Now let's try this problem. Here we can take x common from this expression. So let's see what happens. It's x square minus 3x minus 1, and here it is x square minus 3x plus 1. Now observe this. This is a minus b and this is a plus b, right? So a minus b into a plus b will be a square minus b square. So what I can do is x square minus 3x whole square minus 1 square, right? This x is outside the bracket, so I just take it outside the bracket. Now what? This is what? A minus b whole square, that is a square minus 2ab, that is 2x square into 3x minus 1. So it's x4 minus 6x cube minus 1. I'm sorry, I forgot one term over here. It is a square minus 2ab plus b square. So I forgot 9x square. So now this is x4 minus 6x cube minus, plus 9x square minus 1, right? So if we multiply this x to the each term, it will be x raised to 5 minus 6x raised to 4 plus 9x cube minus x, right? Now let's try this problem. Here further, this is a plus b and this is a minus b, right? So a plus b into a minus b will be a square minus b square. So 2x 4 minus 4x square whole square, that is a square minus b square. Now this is what a minus b whole square format. So that is a square minus 2ab plus b square, right? And this is minus 1. Now this is 2x4 whole square will be what? 4x raised to 8 minus 4 2s are 8, 2s are 16, x raised to 6 plus 16 x raised to 4 minus 1, right? So this is the expansion of this. So I'm sure you are getting algebraic identities now and their application and usage as well. Friends, will be doing more problems based on algebraic identities in our next session. Do revise this session and the previous session as well. So we'll be learning more applications of algebraic identities, right? Bye-bye.